Circles. Circles are named by their centers. All points on the circle are equidistant from the center point, as you can see in the illustration below. The radius is the distance from the center of the circle to any point on the circle. The diameter is the distance across the circle. It is twice the radius, so we can calculate it using the equation 2 times radius, or 2r. The circumference is the distance around the circle. It's calculated using the equation 2 pi r, or pi times diameter, since the diameter is twice the radius. Let's discuss important equations and calculations in concerns to circles. The area of a circle is pi times radius squared. Let's take a look at an example. If the radius of a circle is 4, what is the area? So let's take the equation pi times r squared and plug in 4 for r. 4 squared is 16, so we have pi times 16, which simplifies to 16 pi. A chord is a line segment linking any 2 points on a circle. A tangent line is a line touching a circle at one point only. Check out the illustration below to see examples of a chord and a tangent. An arc is a portion of the circumference of a circle. The length of an arc is calculated through the equation x divided by 360 times 2 pi r. Let's take a look at an example. We'll stick with the same circle from the last example. A circle with a radius of 4, and an arc with a measure of 80 degrees. What is the length of the arc? We'll take the equation x divided by 360 times 2 pi r, and plug in 80 degrees for x and 4 for r, and we'll have 80 divided by 360 times 2 pi times 4. Multiply 2 times 4, and we have 80 divided by 360 times 8 pi. 80 divided by 360 reduces to 2/9, so we have 2/9 times 8 pi. 8 can be written as 8 over 1, so multiply the two fractions and you're left with 16/9. So our answer is 16/9 pi. A sector is a portion of a circle. The area of a sector can be calculated using the formula x divided by 360 degrees times pi r squared. For example, let's use the same circle we've used in the last examples. A circle with a radius of 4 and a sector with an angle of 80 degrees. Find the area of the 80-degree arc. We'll plug in 80 for x and 4 for r, and we have 80 divided by 360 times pi times 4 squared. That simplifies to 2/9 times 16 pi. 16 can be written as 16 over 1. Multiply the fractions together, and you're left with our answer, 32/9 pi. The GRE may combine shapes such as squares, rectangles, triangles, and circles into the same figure. Let's take a look at an example. Find the measure of angle A. So we're given 130 degrees for one angle of the triangle. As we'll cover further in the triangle lesson, the 3 angles in every triangle always add up to 180 degrees. Knowing this, we can subtract 130 from 180 to get 50 degrees. Because the triangle is inscribed in a circle, the base of the triangle is a chord. This means that angles A and B are equivalent. Simply divide 50 by 2 and we have the measures of the 2 angles remaining, 25 degrees. In the figure below, the circle is inscribed in the square. The square has a perimeter of 24 meters. What is the area of the shaded region? As always, let's break down the information that the problem gives us. We know that the square has a perimeter of 24 meters. So the question is asking us to find the area of the shaded region, which is the difference between the square and the circle. This means the way we'll find the area of the shaded region is by subtracting the area of the circle from the area of the square. Let's start with the square. The question tells us the perimeter of the square is 24 meters. Because it's a square, we know that every side is equal. We'll touch on this more in the quadrilateral lesson. So all we have to do to find the length of each side of the square is divide 24 by 4. This gets us 6. Now to find the area of the square, all we have to do is multiply the length of the square by the width of the square. 6 times 6 is 36, and that's our area. Now let's find the area of the circle. As discussed in the lesson, our equation is pi times r squared. Memorize this. Because the circle is inscribed in the square, we know that the diameter of the circle is 6, because the length across the circle is equal to one side of the square. To get the radius, we just need to divide 6 in half, and we get 3. So plug in our radius of 3, and we have pi times 3 squared. 3 squared is 9, multiply that by pi, and we have 9 pi. Take a quick look at the answer choices, and you'll see that they all have pi with a coefficient. So there's no need to simplify this further. So let's take the area of the square, 36, and subtract the area of the circle, 9 pi. This is our answer, 36 minus 9 pi.